Hello, welcome. Azure DevOps Security Lessons Learned. So I mentioned it just before, I kind of fucked up my presentation. So we're just gonna go ahead and skip a couple of slides. The agenda for today, well, we're gonna start something like this. We're gonna look at different ways of hacking shit in Azure DevOps, or hacking shit, actually just breaking stuff. Hopefully we're gonna pass this guy, and in the end, our hacker guy will hopefully look more like this. Sad hacker guy is good hacker guy. So I actually had a long sort of slide setup of the title and why and the lessons and the learning and so on. But then Microsoft, I shouldn't say about me as well. I do stuff, I have titles, and I'm a DevOps and Azure consultant at Advania Knowledge Factory in Sweden, where I spend most of my day writing code or doing DevOpsy stuff, whatever. 3 weeks ago, Microsoft released this one. And I decided that instead of just showing random demos of things I can break, let's map my demos into this little threat matrix that they have and see what I'm actually doing, what they think I'm doing. So we have everything from initial access, execution, persistence, privilege escalation, credential access, lateral movement, defense evasion, and the last two are impact and exfiltration, which I will not show you because once I'm in, I can do any of them and whatever I want. So, let's start with some initial access. And by now, we're not getting any more slides like that because, see, my screen takes a couple of seconds to do this. We are going to look at one of my favorite little quirky and weird settings in Azure DevOps. I'm going to zoom a bit so you can see the weird and quirky settings in Azure DevOps. Oh shit, sorry. I hope everyone heard me anyway.
Oh, yeah.
Good, I tried to speak loud. We have a setting in here called Allow Public Projects. Can anyone guess what it does? Well, it allows public projects and can create public projects with it. Right? You can even go into the documentation if you want to read more, and it says that if this setting is enabled, you can create public projects. Makes sense, right? I have a brand spanking new console. This is not authenticated in any way, it's just a newly fired up console with everything, and we're going to run a command here. Shorthand, of course, okay, console. Invoke REST method to my Azure DevOps organization /_APIs. We're going to run the options method, and we're going to expand the value because that's where the fun is. So what do we have here? We have a list of every single API endpoint in Azure DevOps. Now, before I move on, I actually talked to some guys at Microsoft about this, and this is not a security issue by default. It's just a weird quirk. But this is a list of every single API endpoint in Azure DevOps, including undocumented and unreleased ones. I think I switched the right switch.
Yeah, I can't.
Better? Oh, yeah. This is hard. Sorry. Okay. Damn, that's loud. So we have a list of every single endpoint in Azure DevOps, including undocumented ones. This is a really fun list. Now, I don't think you can extract much from it by default, unless, like, there's a couple of differences in how many API endpoints are exposed and so on. So there might be some change or differences between how old your organization is or what features you have activated. But enough about that. Let's go in here and turn off public projects. Click Save, and let's try that again. This time we get an error saying the user is not authorized to access any of these resources. And I find this really interesting. Again, it's not a security per se, but it tells me two things. First of all, what this setting actually does is expose public everything. Every single API you can call, you can now call publicly. Second of all, there's an anonymous user in every single Azure DevOps organization named that does all the anonymous access for you. And as we all know, never in the history of ever has a strictly named user has issues. Of course. So, again, not the security issue per se, but a great way for me to find out if you are allowing public projects. And if you are, well, then I'm going to try to find them. Why? And that's sort of where we move on from now. So, initial access, public projects is more like public everything. Let's see if this works. Nope. Yay! But if you turn off it if you don't really need it, and our hacker guy will become sad hacker guy. Security lesson number 1, do turn off shit you don't need. We are going to look at some more fun stuff. So I found a public project here. Let's go in and try to do something with it. Starting by dependency tampering. So, according to some research done this winter by Jesse Howing, absolutely brilliant person, and the link to the actual report is in my slide deck, approximately 40% of every single task that you can import from the extension store is insecure. It contains badly written code or old dependencies, or in many cases even strictly says so in the code, like don't run this because it's bad or it will do bad stuff to your organization, and then someone decided to publish it in the extension store and you can just run it as a task in your pipelines. Now, there are good parts about this. If we go look at our extensions here, there we go. Come on, internet. Extensions are self-updating. If there's a new version of an extension, it will automatically update that extension, so I will always have the latest version installed in my Azure DevOps organization, and that is good. There's also a bad part of it. Can anyone see what's wrong with this? Because I couldn't. I had no idea. I'm doing some Azure file copy stuff here. So if we go task : Azure file copy, we can see that there's actually a version 5 of this released. Now, I don't know what the difference between version 4 and version 5 is, but it's not uncommon to find security issues with those tasks. Someone has to build them, and we're human. We build bad stuff. So we kind of need to keep track of this as well, because dependency injection is quite easy to do, because most people just fire and forget. You write a pipeline and then you forget it. So, quick and easy. Security lesson number 2, an Azure pipeline needs to be alive, just as your code should be. And we have a sad hacker guy. Before we leave this one, there's also another thing I want to mention. We have in our pipeline settings here the possibility to restrict tasks, what tasks we make available to our users. There is one setting here. So a task has to have a runtime. We have 5 runtimes that we can choose from when we build tasks in Azure DevOps. You can use PowerShell, PowerShell 3. It's not PowerShell version 3. It's just different versions of the runtime. We can use Node 6, Node 10, and Node 16. Anyone can tell me when Node 6 went out of support? Because I was hardly born when Node 6 went out. No, it's like, I think it was like 6 or 7 years ago they stopped supporting Node 6. Yet people still develop stuff in it. And again, if we have bad dependencies, well, dependency injection as soon as we get somewhere is really easy if you keep using this. So I would absolutely suggest disabling Node 6 tasks if you can. If you do, and people are using them, they will break. So perhaps not just go home and switch it on without at least giving a warning, but it's worth trying to at least. There is coming a disable Node 10 tasks as well, because Node 10 is also out of support and old. So yeah, when that comes, you probably should look at trying to disable this. You could also disable marketplace tasks in totally. Makes it harder to do stuff because marketplace tasks are actually useful. Disable what you don't need. Again, if you're not using it, turn it off. Sorry about that. But enough of the jibber jabbering. Let's go look at some fun stuff instead. turn shit off, that's all. Um, let's look at some poisoned pipeline execution. And this is where it kind of gets funny, because we know now that, okay, I can find your public profile. I can see if you allow public projects. If you do, let's just assume I found one. I sneak my way in. Let's go look at quite a standard pipeline, or a repo. I should have done this. Here, we have quite a standard setup for PowerShell nerds. We have a module with some module files in. I'm not going to show them because it doesn't matter. We have a tests folder with some pester tests in, because of course we have pester tests. We have a build script, and we have 2 pipelines set up. One default or main, sort of the build pipeline, the one that runs when something is merged into main, and one that we run whenever someone creates a pull request. This is quite a common thing to do. I mean, I do it all the time. We want to run tests when someone creates a pull request, right? We can go in and see how it looks in our settings. Oh, sorry. Where are we going? Where are we going? Nope, 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 nope. Let's go back and do this again. Because I completely lost track of everything. I just forgot. Let's go click my link instead. And hope this is the right one. I completely forgot how to find this link, which is interesting. So when you set this up, I would absolutely suggest you also enable this one, require a minimum number of reviewers, so no one can push right straight into main. Makes sense, right? But that's not what we're looking at. We are going to look at this one. This is the verify pipeline as it is in Azure DevOps. It says, build validation, validate code by pre-merging and building all your pull request changes, and we have my pipeline set up here. So let's go back and read that once more. Validate code by pre-merging and building pull request changes. Your validation pipeline will merge whatever it's done and try to run it. So, who can create a pull request then? Okay, come on. I clicked you. Readers can create pull requests. As long as I have read access to your repo, I can create a pull request. So let's go do something fun with that. Like I said, just normal module. Assume for a couple of seconds that I don't have access to this project. I only have read access, that's all I need. What we can do as soon as we have read access is create a fork of it. A fork is basically just downloading stuff to your own place and setting up a remote that points to this. Here we can see now, oh yeah, this is a fork. It says this is the remote, this is where it's forked from. We're in a different project, PSD of 2023 work. This is a project I can write code in. So let's go into my, oh wait, wrong one, this one. Let's go into our verify pipeline and do some fun stuff. Just like this. And we can say, doing nothing evil. Doing the evil. And of course we need a write host in before and so on. Because that's the way we do it. So again, this is a place I can write to. So we just do like this. And because it's a remote setup, we can create a pull request like this. And this pull request, if we, let's see where I'm at. No. Doop. Oh. It would have been easier if I remembered how to do this. There we go. They changed the GUI. Let's create a pull request. Now, just as we said, we have set up a verify pipeline that will now be run in our repo where I do not have access. I'm back in the PSDO 2023 repo. We can see up here, oh, I should not have clicked that. And we can see that, okay, it runs whatever. It runs our pester tests and whoopsie daisy. I'm in your pipeline doing the evil. Now imagine if this is like the pipeline that deploys your infrastructure. I just, with reader access to your repo, wrote stuff to your Azure environment. Thanking you very much. But we can solve this in actually multiple ways, but I don't have the time. So we're going to look at one way to solve this, because we can separate our stuff. So instead of having Azure pipelines and the actual code that does the stuff in the same repo, we can have one repo with only code. And then we set another repo up with only the pipelines. It requires some more changes to be done. We need to set up this one to trigger on nothing. And we must set the code repo up as an external resource, so it knows that, okay, when I run, I need to clone this. We also need to say, okay, trigger on whatever. In this case, this is the build pipeline. Trigger on main on this repo instead of the main. There's like a couple of settings we need to change. We need to add manual checkouts because Azure DevOps doesn't understand manual checkouts when your repo and code differs. And we need to fix paths to whatever it is we're doing because it checks them out. So there's a couple of differences in how we write our pipelines. But if you change my pipeline repo now, then absolutely nothing will happen, because even if you do change it, I don't have any triggers. No pipelines are run in the pipeline repo. And if you change my code repo now, oops, sorry, too small. Code repo now, well, I have to approve it, look at the code, merge it into main, and it's not until then it's like nothing happens. We still run the same pipelines, we still run the verify pipelines, we can run verify pipelines from any repo and so on and so forth. So that's not an issue. So, security lesson number, I have forgot which number, so let's just say security lesson number anything. Separate your code and your repos, code and your YAML repos to prevent people from running code wherever possible and whenever possible and accessing stuff that they shouldn't access to. Because read access is all you need to run a pipeline. All good so far? Everyone's sitting there like, oh, fuck, I'm gonna go home and move everything to different places. Good. So we have found ways to, I don't know, oh, look, you can zoom in here, nice. We have found ways to grant ourselves some initial access or find public repos. We have executed some code, and if you have old tasks running node 6, well, congratulations, I have executed your code and used exploits at the same time. Fun stuff, fun stuff. But if you fix this, I'm out of luck, because we need to grant ourselves some persistence. We are going to do something fun that I call test-driven destruction. So there's still issues here. We have separated our pipelines. No one can tamper with our YAML. That's awesome. But if you were to contribute code to any of my repos, apart from PS Secret Scanner, because I don't give a shit about code quality there, I would probably say you need to add tests as well. Because tests are good, because I want to know that the code you write for me works, and so on and so forth. So let's add some code, shall we? And we already know that I can fork because I'm a reader and I can clone and all of that, so I'm not going to go through that process again. We're just going to add some tests for my code. And I'm going to copy the code of my tests because I can't remember what I should write. Thank you. There we go. So we're adding a super good test to my function. Oh, it's really hard to zoom with the... We're adding a super good test for my function, and it will work really good, and it will do stuff, it will write stuff, and it will write that stuff to a file, and you can probably figure out where this is going by now. Now we should do a branch Oh, sorry, that one. There we go, and we can automatically create a pull request right away. It will, of course, hopefully, if everything is done, it will run our builds or our verify pipeline, and it will look fine and dandy. Like I said, you probably can imagine what will happen. The test will shine green because I'm not throwing any errors in my tests, right? Now, of course, it's just a one-line test. I could obfuscate this in a million lines of code, write a million tests for the code I'm adding, and just sort of sneak this in behind the lines. Runs green, everything is fine. Let's just merge it. We don't care about how. Good. It's merged into main. We can go look at our pipelines, and we have queued up a build. And hopefully it will not take that long, because we don't have that long. It will do everything it's supposed to. It will run my pester tests again, because it's a build script. I want to verify that everything is done when I build it. And it will run our build script, and it will fail on the next step, but that doesn't matter. Because I just wrote code from my test into your build script, and now I'm back in your pipeline again. And if I can write back to your build script, I can write back to everything I have write access to, which in this case is most of your machine. And if you're, for example, running self-hosted machines, that includes a lot of good places to write code to add persistence to my code. You can now fix this pipeline. I have already created my persistent actions in it. Thanking you very much. But we can fix this. So how do we do this? Again, there are many ways. Because one of the main issues here is that sort of you should move most of your build stuff outside of the normal pipelines, but tests can't be moved. Because I want my tests connected to my code. I don't want you to be able or be forced to go into like this repo to check out my code and this repo to check out the tests, and then they have to sort of correlate them and try to run them and figure out how this works. I want everything to be in this place because this is code. It's the same life cycle. But what we can do is add more resources to our pipeline. There's a nifty little, I'm from Sweden, I can't speak. There's a nifty little feature in Azure DevOps where you can mount stuff in containers. It's quite simple, really. You just add another resource. Resources is the headline. And instead of adding a repository in this case, we add a container. We have to give it a name, whatever we call it. And we have to give it an image. In this case, I'm using Microsoft's own PowerShell deployed. It's automatically updated to almost the latest version of PowerShell all the time. It works really well, and I run a lot of PowerShell in it just for fun. But there is also a flag in here called mount read only. Mount stuff as read only. In this case, the work folder is everything I'm mounting read only because it's the only thing I need for this demo. There are more folders or more places. It's documented in the docs for this that you can say mount this and do this. So what will happen now is I can tell my pipeline to run this job in my container. There is two ways of doing this. Either you can add your container and tell each step that you want to run in a container to run in this container, or in this case, I'm telling my entire job to run in container, but the build script still needs to be able to output data. There's no point in building stuff if it will just fail in writing back, right? So we just say, okay, this particular step will target our host. The rest of it, run it as read-only in our container. And hopefully we can see, let's just do it this way instead. If we do this, let's look at my last run of this. What will happen is it will try to run our entire pipeline, just like it did before. Everything will look fine and dandy up until we come down to run pester tests. Now, like I just showed you, I used the pester test to write back to your code. Now, we get an exception, read-only file system. Good, you can add whatever you want into my tests. As long as you keep yourself in the test folder, that's okay. You're on a read-only file system. You can't alternate anything here. Now I'm not saying I'm not saying this is a flawless solution, because in some cases, Pester actually needs to write stuff, and you have to sort of filter out because you, I don't know, need to create test files on the fly or whatever. But it's a working solution. You can do this by figuring out which folders to write to and which folders you need to write to and so on. So it's not a perfect solution, but it's a solution, and it's fun to demo solution. Security lesson number, whatever number we're at now, 4, test-driven destruction. Use containers to prevent stuff from writing where it shouldn't. And again, we have a sad hacker guy. You can use containers for other fun stuff as well. There are, of course, if we go back and look at this again, a couple of small things we need to think of when we add containers to our pipelines, except from the fact that we actually add the pipeline. Oh, I think. There we go. Except from the fact that we're actually adding the container, we also need to, for example, Pester isn't installed in this container. There is no Pester in it, so we need to sort of take care of that as well and so on. But yeah, it kind of works. Use containers to separate stuff, and our hacker guy will be sad hacker guy. Goody goody. So we're in, we have gained some persistence. Now this one I haven't added any orange blob to because I don't really know where to put it actually. It's just like a fun thing that people tend to do wrong more than a regular demo. We are going to see if we can escalate our privileges. How many of you people here administrate your own Azure DevOps organizations? That's a good number. How many of you people here run your day-to-day computer as domain admin? Well, that's also a really good number. 0 is a good number. If you are managing your Azure DevOps organization, I really can't speak today. Chances are fairly big you're a member of Project Collection Administrators, right? I know I am. You shouldn't be. Project Collection Administrators is God mode in Azure DevOps. Access to this one gives you access to everything. Like, you can change whatever you want to. And there are ways of sort of fooling us. Oh, by the way, before I go on, there is also a setting in here. You can be owner, organization owner. Organization owner is basically the same thing as project collection admin with the added feature of being able to retake an organization if it's lost. So, first thing before we move on, if you are organization owner like I am here, you should probably use a break glass account for this instead, because it's better to not be personal if you sort of disappear. And also, this is really dangerous. But anyhow, back to our permissions. Project collection administrators can do all kinds of things. So if you are a member of this, and I am in your code on your machines, and you sort of, say we're back to running your self-hosted machines. I get persistence there. I wait until you go there to fix a bug, because I injected a bug in your pipeline. Congratulations, you just logged in on that machine with your account, and I now own every single thing in your Azure DevOps again. Thanking you very much. How do we fix this? Well, in Azure, we have a role called Azure DevOps Administrator. Makes sense, right? If we're a member of this, we're the Azure DevOps Administrator. Wrong, you are not. That role only gives you access to everything below this point, policies in Azure DevOps, Azure setup. But we have another little nifty feature in Azure called Privileged Identity Management. This is a really nifty feature. It's actually one of the best things I think Azure has implemented when it comes to user management. This is basically short-lived membership stuff. In here, we can add roles, but roles aren't supported in Azure DevOps, but we have privileged identity management groups. This is a normal Azure AD group you create, and then when someone wants to be a member of it, you have to go into Azure, and you have to say, please make me a member of this group for yay long, and you can set it up either magically to work, or you can set it up to ask for a approval of some kind. Your manager needs to say, yes, it's okay, Björn can be admin today. Or you just send an email, okay, Björn just became super duper admin. It's at least some kind of notification that something's going wrong. And instead of doing it this way, that I'm doing, because I'm a bad person, you add this group to Project Collection Administrator. And then every time you need to do something in organizational settings, PIM enable that. Yes, you have to log out or log back in, because that's how tokens work, so it will need a token refresh in Azure DevOps. But if you're using PIM groups for this, then you don't get access to this. If someone gets your account, then at least you're not giving them the account to the kingdom, because you're deploying everything in here, right? We don't want to give someone the keys to the kingdom. And you can still have access to all your projects where your code lives. That's not an issue. That's another Azure AD group, right? And there will be people, I'm not saying anyone here because we're the good ones. There will be people who say, no, but I need this, I need to do stuff in here. So, but if you're in organization settings doing stuff every day, then you're doing it wrong. And I can probably tell you how to change that behavior, because most of the stuff here, I mean, I work here daily. I spend most of my days in Azure DevOps, and I touch my organizational settings on demos when I try to break shit. It's like you rarely go in here. It doesn't need to be here. So do not be super admin. Lesson number 5, use PIM to make hacker guy sad hacker guy. Because just like you do not use domain admin on your computer or global admin in your Azure account, stop throwing away the kingdom by being local administrator in between or a super administrator in between. Don't just protect that one and that one. We need to remember the parts in between. Remember the powers you're given. Okay? Goody goody. We have escalated our privileges because you were super admin. So, of course, we're not happy with having 1 or 2 accounts. Let's see where we can get some more. We are going to go back into our pipelines again. Zoom out a bit. I have commented this part out, so for the sake of ignoring, just ignore the fact that it's commented out. In our pipeline here, we are deploying stuff to Azure. I'm running some randomly Azure file copy because that's what it was when I set up the pipeline. And we are running on Ubuntu latest pool, Azure hosted images. Right? Good, all fancy. If you are to do this, if you're deploying Azure stuff from here, let's do this correctly. Zooming is weird. Nope. Fuck, this isn't gonna work. Go in. Shut up. Sorry. There we go. So, if you're deploying stuff to your Azure environment, let's hope I don't trigger a pipeline right now. If you're deploying stuff in your Azure environment and you're doing it from a Azure hosted system, you're probably using something like this. You're setting up a service connection into Azure, and then you're using this to talk to Azure, right? So what's a service connection? Well, it's basically a service account, an account. Contains username, secrets, and it probably contains a lot of access to your Azure environment. And now, this is fine. Like doing stuff like this, it works good if you're sort of doing simple stuff. If you were to deploy it to publish to PowerShell Gallery, run on Azure hosted machines because they're absolutely brilliant. You don't have to take care of everything. And any new stuff we throw into our pipeline is a new way of breaking shit, right? But if you're deploying to Azure, you're going to need to unlock access to your ARM layer from Azure-hosted machines that anyone can run anywhere in the world from Azure DevOps or GitHub, because it's the same runners in the background somewhere. Like, you have to unlock your ARM layer quite a lot to be able to get this to work. Because, well, I mean, it does work default, but if you have a secure Azure environment, it won't, because they won't allow you to do this. They shouldn't allow you to do this. But there's a nifty little feature in Azure DevOps. I like nifty little features. Apart from this, apart from running on Azure hosted, we all know we can run on self-hosted, right? We can set up an Azure VM scale set to run our code. So an Azure VM scale set is basically a virtual machine in Azure that scales sideways. So whenever I request one resource, it will scale up a new machine and do whatever magic it needs to do to get upscaled, and we can use custom images or Azure-hosted images just like a normal VM. The neat difference is that Azure DevOps can help us sort of tear up and tear down and make these ephemeral resources. We still have to create a service connection like Yay, because it still needs to talk to Azure. Azure DevOps still needs to tell Azure that, okay, I'm running a pipeline, I need a new host. But this service connection actually only needs 2 roles in Azure. It needs, it can be limited, scoped down to the very scales that you're running on, and it only needs, I think the roles are called like VM scale administrator or VM scale repair or something. I don't remember the names, we can look at it if you want to. But it only needs 2 roles to be able to scale up and down the VMs and repair them if they need to be repaired by updating or adding a new software to run on it, right? So once we have created our service connection, we can lock that down to those 2 roles. And then we create an agent pool like this with our Azure VM scale set in it. And this scale set, we can do some fancy, nifty little settings on if we click the right button to say, okay, first of all, don't keep any on standby. It's faster if you have one on standby, but they cost like a VM, so having them on standby for the sake of it just makes no sense. But above all, this one, automatically tear down virtual machines after every use. If you check those 2, and you lock down your VM scale set access, then what will happen is I will run a build pipeline or a release pipeline or whatever. It will scale up a machine, it will do my job, and it will toss it away. So even if I get access and can write stuff to it, it's gone. It's gone right away. And like I said, you can lock the access from here down. But another really cool features of this is that once you're using Azure machines, instead of having service connections, which is a username and a secret, we can do stuff like this. I hope you can see what it says. It says, there we go. If we're using machines in Azure, well, congratulations, you can use managed identities. Fantastic features, because managed identities, it totally moves away the requirement for you to manage any kind of secrets. You don't have to take care or bother about it anymore. Managed identities does that for you. It's kind of easy to lock down the managed identity in Azure. You can say, okay, I'm just deploying to this Azure storage account, so give my managed identity access to this storage account. And even if I break into your pipelines and take everything over, the worst damage I can do is pushing stuff to that storage account, because that's the way you locked it down, right? Nifty and fancy. An added bonus of this is the very concept of secrets and secret storage. So let's just for a moment assume I want to actually have a secret or have something stored somewhere. I need to have a username and password for server X inside my internal network. Now we can store those in Azure DevOps. And Azure DevOps secret store, it's good. It's 2048-bit encryption. It's pretty safe. And have you read the sort of guarantees for secret store in Azure DevOps? It states right out that this is a best effort. We try to keep this as secret as possible, but if it's exposed somewhere, sucks to be you. And I so far haven't managed to expose a secret in Azure DevOps Secret Storage. So again, it's good. I'm not saying that. But secrets in transit are bad. If you have your Azure host up here, Azure DevOps services or server up here somewhere, and then you unlock the secret because you need to read it on your machine, and then you transport that secret to your internal build machine, and then you do whatever it is you want to do. That's 4 places where we can sort of steal this secret. If we get access to any of those places, congratulations, you're toast. Secrets in transit are bad for you. Using a managed identity on a VM scale set like Yay, well, lock it into a Azure Key Vault that states that we do protect your secrets. The service avtal, I have no idea what the word, because I don't remember. The contract for that service agreement, thank you. The service agreement is way better. So if something happens, Microsoft may actually support you to get stuff fixed. And you can use your managed identity on your scale set to unlock it and use it, and suddenly there's way less points of failure. Okay? So, if anyone's keeping track, lesson number 6. Use managed identities and private endpoints, which I didn't mention, but that's also a nifty feature in Azure, to protect your connections and prevent them from gaining too much access. And also, secrets should live close to usage. If you're using your secret in Azure DevOps in your first steps on a build agent there, absolutely do so. But try to prevent them from jumping from host to host, and try to prevent the closer the steps are for me to pick them up, the safer they are. Goody goody. We have done a lot of fun stuff to gain access to your pipelines, or to your code, or to your environments. But we need to be able to move laterally, right? So this is quite a boring demo, but let's look at it anyway. If we go back to our service connections, let's go in here, to our agent pool. We can click security and check the security here, and we see that this pipeline has access to my VM scale set, right? We can go into settings, and we can click the service connections, and we can click security here, and we can see that, okay, this pipeline has access to this service connection and can scale our agents upside down. And if we click edit here and see how it looks when you set this up, there is a little button down here called Grant Access Permissions to All Pipelines. How many of you have ever checked this box? Bad person. I'm not trying to hang you out, but just so you know, I click it all the time because it's easy. So the thing is, I don't know how many companies I've been to where sort of they say like, set this up, check this box, and I'm like, stop it for a second here. So this is called a protected resource, and they exist sort of everywhere in Azure DevOps, all over the place are protected resources. And they have this button in one way or another, grant access to all pipelines. And well, what it does is basically removes everything we have bothered to lock down before because, well, I get access from whatever pipeline. It locks down your access token or prevent your access token gets locked down from accessing this resource. So you're actually good people. Most of the times I've mentioned this, there are at least a couple of more people that raises their hand. But my point kind of is, this one prevents, or do not check this button. It shows up everywhere, and don't ever check it. Like, simple as that. Protected resources are protected for a reason, and if you grant access to everything, well, if I gain access to one pipeline, and you have sort of, even if that one does nothing, but then you have your scale set that has a managed identity and has access from every pipeline, well, I just need to create a new task in this pipeline and say, run on this scale set and use that managed identity to do whatever I want over here. It's just a matter of sort of figuring out where you have done all of these things. Short, rather dull demo, but lateral movement. Do not check the checkbox. Never check. It's that simple, really. So, we're in. We've taken over your environment. I now own you. And you, of course, know everything about my existence, right? We're going to go back and look at some policies. This one, log audit events. I'm gonna, oh shit, I go over time. Log audit events. Did you know that if, depending on when your environment was created, this is off? Yeah, that's bad. Just go in and make sure it isn't, because that's sort of the only biggest red flag you can have in your environment, because this is the only track you will have of if anything happens in here in your organizational settings. If you turn it off, well, turn off logging. It's bad for you. But that's not all. I'm getting closer, done so. No worries. I hope I'm not stealing too much of your time. If we have it enabled, well, we get logging. We can tell what to do, what happens. Azure DevOps logging is decent. It's okay. But it's not flawless. There are some stuff missing here. But even bad logging is better than no logging. But in this case, well, searching in here, it works. It's kind of bad. And you can export it and read in Excel if you prefer to. But don't forget to do this as well. We have streams in Azure DevOps. So forward your logs to Azure Event Grid or Azure Monitor or Splunk. You can use Event Grid to forward it to whatever environment you have. Because Azure DevOps not only sort of is bad to search in, it also has a retention policy of 3 months. So if I've been in your environment for 3 months, you have no idea. Okay? Set up log forwarding or, security lesson number, whatever, 8. Those who do not remember history are doomed to repeat it. If you do not have logging, I'm probably not the only one in your pipelines in a while. Set up log forwarding, and we have sad hacker guy. And by now, we can actually do this because I'm done with demos. So, are we pwned? Well, we granted ourselves some initial access, we executed some code, and we even managed to do some dependency injection. We gained some persistence by writing to other places than our default file pipelines. Escalate the privileges because you are always member of all the groups you shouldn't be members of. Of course, we use VM scale sets, so I can't steal your credentials. We also keep your secrets in Key Vault. And no one checks the checkbox. And of course, we set up logging right in the end. So even when I do bad stuff, you can see me. Even after a while, you can see me. Even if I go in and turn off the logging, well, at least the traces up until I turn off logging is there to find. Now the rest, the 2 last ones, I made them green because once I'm in, I can do whatever I want. If I want to DDoS you, or if I want to, whatever. I can do it, so I didn't even bother. But we also looked at some ways to not do that here. And hopefully, we have a sad hacker guy. And with that, you can find me in any of these places. It's Mastodon or my webpage or my GitHub. Are there any questions? Hmm?